Hey guys, good to see you again. I want to talk about something that you don't see discussed much anywhere else, and that's the impact of fault directions on gold formations. So, what causes the gold to come out of solution? So, let's have a look at a map. For example, here's WA, and this is, I will turn on the faults, for example, that are across the countryside. You can see there are all sorts of different directions and everything else. I'll just zoom in a bit, no particular area, just zooming in a bit. And I'll actually turn on the gold locations. Okay. Each of the yellow represents a gold discovery, deposit, or mine. And if we look at some of these places down here, you can see a lot of gold along this direction of a structure, as you can see, and some over here, but very little up here. And then back here, there's some along that structure, not much along that way, not much along this one, and basically bugger all along here. So if you look at here, and I'll just do some changing of the opacity, you can actually see how they honor the various changes in strike of the fault match the occurrence of gold. And you can look down here again, say, I'm not saying that all gold falls on this northwest-southeast trend. It is common in the southern part of the goldfields, but it's not common everywhere. But what you have to do is do your research for the area that you're interested in, because subtle changes in strike of a fault can cause gold to come out of solution. So why is that? Why does gold come out of solution in a change of strike? Okay, let's demonstrate this in a simple sort of way. So we're looking at a plan view here. So we've got a fault coming along. We've got a fault coming along over here. And on this side of the fault, it moves that way, and this side moves here, this way. And so basically what we've got is we've got the two moving like this. Classic sort of Hollywood-style fault. Faults, as we know, are the major conduits of fluids coming up from deep in the crust, and we're talking tens of kilometers down, and they move up into the shallower parts of the crust. Historically, has always been thought to be around about 5 to 10 kilometer depth mark. The pressure drops off sufficiently that gold will come out of solution. Okay, now, so we've got a fault, and you can see the classic movement. So if I draw another fault, and I'm going to change colors here just because I can. But in this case here, the fault comes up and bends like this and goes that way. And we're still going to have the movement on this side of this way and that way. Okay. What do you think happens in this zone here? Okay. And this part is moving this way. This part is moving this way. So basically, it's getting crushed together. The rocks are just basically welding themselves together. There's almost no chance of any fluids or anything coming up in that particular zone. But if we've got another fault, let's draw another blue one. And I'm just going to get rid of some of these up here. Now we've got another fault that comes along this way. Okay. And we've still got the same directions, this way, this way. What do you think happens in this zone? Okay. This side's pulling apart this way. This side is pulling apart this way. So this starts to open up. And what happens is that you'll end up with a fault that starts to, a structure that starts to look like this, with a gap in the middle. And this gap can get filled in with fluids that are coming up from depth and precipitating out. So you may find that over a length of a whole structure, that again, so over a whole structure, you may end up with a fault that goes like this. And if we still have the movement in this sort of direction, I'm going to draw the red spots where you're going to get the opening up of the gaps. So we're going to get an opening up occurring here. We're going to get an opening up occurring here. And I'll put some orange to represent the compression zones. This is going to happen in here. So when we're looking at the map, you say, okay, overall, let's use a green here, that this fault has a strike of that direction, but you can see the local perturbations. Oh, that's a fantastic word, isn't it? Perturbations inside the fault. And each of these things can be a potential gold forming trap, especially if it runs into a zone where it intersects iron rich rocks as well. So this is saying that this area out here, these red zones, are zones that are most likely for gold to precipitate out of solution. And if there is a band of, let's say, I'll get drawn in green, but let's say there's a band of iron rich rocks running through here, you get up a chance of some very, very rich grades coming out in solution in that spot. So going back to our map again, so you can see on this map that we've got potential zones that have opened up on a macro scale, that these faults are more likely to open up. But in each of these zones here, we're likely to see the fault itself is most probably weaving around. And so in this one here, it's most probably the fault could be weaving around like this. In some places, it is compressing, and other places opening up. So it looks like it's all running one particular direction, but there could be local areas. Not always the case, but there could be. And so in these changes of direction, you could end up with some very high-grade deposits. I worked at a mine site, a gold mine in the southern parts of the goldfields, basically when Pontius was a pupil pilot. And the mine was a high-grade mine. Don't get me wrong, it was like 10 grams per ton underground mine. And what would happen is that, I'll just drop back here to the drawing tool. And what would happen in this mine site, and if you look again, looking in plan view, so this is a quartz vein coming along. It would come trundling along. This is plan view, so we're looking down from the top. And all of a sudden, it would intersect some sort of structure. And these were very, very small structures. And the quartz vein would roll and continue like this. And then it would roll again and continue. Now, in these zones here, okay, were significantly higher grade than these zones out here. So this is a zone that would average, say, 5 to 10 grams per ton. The area inside here, inside there, we were talking ounces to the ton, which is 31 grams per ton. So we can talk sometimes multiple ounces of gold. And I remember being underground at one time when the airlag miner broke through to this, and the whole face was just gold. And it was like insane. Wherever you pointed your cap lamp, there was gold everywhere. And they mined it out, got to the corner, and you could see the quartz vein turn, and the grade dropped right off almost instantaneously to back down to the normal sort of values, and it continued on. Thinking of this, what was causing this, it was still much discussion, but it appeared to be a number of cross-cutting structures caused this. But you can see how the quartz vein came in, which was obviously following an existing fault that ran this way through the rock unit. And you could imagine, and I'm trying to find a good color here, so this would have been the areas of movement in this quartz vein. And so as it got down here, it turned this way, this opened up, formed a zone, gold precipitated, and these were like vertical pipes that extended down 100 plus meters, and then they would usually peter out again as the quartz vein changed out. Dips of the various structures changed. So going back to the map, when you're doing your research, look for the structures. And if you can see a particular trending structure, and you can see, well, This is all along the structure here. This is direction. Find things that are in your area. As you're walking around the bush, look for foliation in the ground. You can see sometimes it's like what looks like pages of a book standing up, and that can be the broken up, almost like a slate-like structure. It's not slate, but looks like it. And that's the direction of the faulting. If that honors this general direction, there's a good chance you're going to be finding gold. So when you get out there, guys, have a look for the orientation of the fault direction. Know which way your gold direction is running and stick on that. Once it starts changing around, maybe time to go and find some new ground. Like, for example, if you look up here, the structures come through here and swing up through here. That's the mapped fault. Point number one, mapped fault. There's an awful lot of faults out there that are not mapped, okay, or not drawn on this data set. This is a data set that comes from DMIRS or DMP now, Department of Mines, Petroleum and Exploration, and it is what is known. There's a lot of faults out there that are not known, never been mapped before. Many a prospector has found some of these structures and kept them a bit close to the chest. Some of these structures here could actually spin off again and go up here and could form more gold. I'm not saying that's the case here. A way to aid you to look for the gold is to start coming into tools like, this is in the goldprospectingwa.com website. You can actually come in here and actually turn on the geophysics. You can also do this in other applications like Trilobite. And then what we'll do here is we'll actually move the structures to the top, and I'll move my gold to the top. Oops, I moved the wrong one. Okay. And so I can see there's my gold sitting on the top. Let's see, make it nice and bright. I can change it back and forth. There does look like some sort of structures running along here. And as we get into here, there's some sort of things running off here. So you could almost say this structure zone has been offset by this one. And it potentially could run up through here. So it's not mapped that way, but time to get off bum and go and have a look, because it could be well worthwhile. And you can see up here, it all swings around here, and we sort of run out of gold. Okay. So look where the direction of the faults, and you can see how they closely tie in with some of the geophysics and how it ties in with the existing gold deposits. I hope you guys got some value out of this today. If you have, I'd love it if you could give me a thumbs up, a comment, and even better if you could just subscribe. Fantastic. Thanks, guys, and I hope to see you on the next video.